Welcome students. Let us see this question. This question is very important for your IB mathematics AA, HL or SL even. So I will discuss two questions. Both are similar to each other, and please try to understand the basic concept how to solve. So the question says $8,000 is borrowed over a 2-year period. So my principal is $8,000 and it is borrowed for 2 years. So time is 2 years at a rate is given as 12% per annum, right? Quarterly repayments are made. Now the payment has been done on a quarter basis and the interest is adjusted each quarter, which means that at the end of each quarter interest is charged on the previous balance and then balance is reduced by amount repaid. This is the general procedure for your EMI, so nothing new. So what we can do here, see, we can write here that it is a quarterly repayment. So first of all, whenever you have these data, so please see, whenever we have quarterly payment, so we have to find how many repayments will be done actually. So we have to find number of repayments. So how many repayments we will do? Since it's a quarterly repayment, it means in a 1 year I will pay 4 times. So in a period of 2 years I will pay 2 into 4, that is the 8 times. So the total number of repayments becomes 8. Next, what's the rate? See, rate is 12% per annum, but I have to pay per quarter. So what will be the rate of interest per quarter, right? So it will get divided by 4 because in a year there are 4 quarters, so we will do 12 divided by 4, that is the 3% per quarter I have to pay. Now let us see. After this, see, suppose we have some loan amount, so our loan started here, right? So after first quarter, this is the first quarter, what will happen? I have to pay some amount, and right, that will be my equally monthly installment, all right, EMI. So I have to pay something, right? So after, let us suppose my payment is R. Let us suppose after each quarter I have to pay EMI as R dollar. I have to pay each quarter R dollar. So what will happen? See, after one first quarter I have paid R. So initially total principal was $8,000. Every charge or every interest will calculated on this principal 8,000. After first quarter, now it will be changed. So how will be what will be my remaining balance after payment of first quarter? What will be the remaining balance I have to find? See, so let us suppose A1 is my final balance after the first quarter. So what it should be? See, total interest before payment will be 8,000 into 1.03 because the rate of interest is 3%. When you convert it in decimal, it becomes, see, like this. So it's a rate, so you can write 1 plus 3 upon 100. So this will be 1.03. If you multiply by this number, you will get directly the total, you can say, loan amount. So after first quarter, actually my total loan was this, right? But I have paid something also. So it should be subtracted from here. I hope you are getting this. This is a very important, you have to understand. See, this 8,000 into 1.03 is the total loan that includes my principal as well as my interest. So this will be 8,000 into 1.03. Rate is 3%. That's a factor value 1.03. If you multiply with this, you will get the total loan amount. That includes your principal as well as your interest. Right. So this should be our total loan amount after first quarter. But I have paid something also. So this will be adjusted here. So this is the case of first quarter payment. What will happen to the next quarter payment? Similarly, if I pay for the next quarter, now I am talking about at the end of second quarter. See, after first quarter, this A1 was my total due, right? After first quarter, this A1 was my total due. So what will be the total due after second quarter? So I have to pay interest on this A1 also. I have to pay the interest on this A1 also, because this is my due amount. So what will be the total due? So it will be now A1 into 1.03. This is the total due, right? Again, I have to subtract it by R, right? Because I will pay the second installment, second quarterly installment R. So this will be, we can simplify this, right? Let us put the X value of A1 here. So what is the A1? Basically A1 is 8,000 into 1.03, this minus R. This is the A1 times 1.03 minus R. See, this A1, this is your A1, 1.03, this 1.03. So when we will simplify this, we will get 8,000 into 1.03 raised to power 2 minus 1.03 R, this minus R. So this is now my total due after payment of second quarter payment, right? Similarly, let's try to find what will going to happen after the payment of third quarter. So we are going to see third quarter. See, before third quarter, or you can say after the second quarter payment, this A2 was my total due amount. This is the total due amount after the payment of second quarter installment. So I have to pay the interest on this A2 as well. So what will be the total due amount after the payment of the third quarter? First of all, total due. So what's my total due? It should be A2 times 1.03. This is the total due amount, but I will pay R dollar as well. So this will be the total due amount after the payment of third quarter installment. Now put the value of A2. What's the A2? See, this is the expression for A2. We have to substitute the value of A2. So this is 8,000 into 1.03 square minus 1.03 R minus R. This is A2. This is A2. This A2 multiplied by 1.03. This 1.03 get multiplied here, and rest negative minus R, this. So we will simplify this little bit also. So this will be 8,000 into 1.03 raised to power 3 minus 1.03 square R minus 1.03 R, and this last R. So we get the total due after the payment of third installment. Similarly, now we can find for fourth, fifth, anyone. Now we have to be smart, right? So now we have to observe the pattern. What's the pattern going on? See, this is the due after second payment. This is the amount. Just complete expression represents the amount due after third payment, right? Is there any pattern going on? Yes, when you will observe, there is a pattern going on. See, if the this is the due after third payment, then this 3, then 2 power, then 1 power, and last minus r. So see, I have to pay total 8 installments, right? See, we have find it here, we have to pay total 8 repayments, right? So it means after 8 repayment, my remaining due should be 0. After 8 repayments, my remaining due should be 0. So directly we will try to write its A8. What will be the A8? A8 will be the remaining amount, remaining due amount after 8th payment, right? So according to the pattern, I will write it simply 8,000 into 1.03 raised to power 8 minus 1.03 raised to power 7 r minus 1.03 raised to power 6 r minus dot 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 minus r. So this will be my due amount after 8th payment. I hope this is clear till now. Right. Now, according to question, after 8 payment, my loans should be cleared. Right. So it means A8 should be, A8 must be equals to 0. Right. So now what we can do, we can equate A8 as equals to 0. And we will try, see, if we equate this A8 as 0, if we equate this A8 as 0, so please see here, in this equation, this becomes now equation, and in this equation we have only one variable, that is the r only. Please see, in this expression we have only one variable, that is the r, and one equation, one unknown, so we can find it very easily with the help of geometric progression. So please see how we can solve this. So let me first write its expression for A8. So what I'm saying, A8 should be equals to 0, and A8 is basically 8,000 into 1.03 raised to power 8 minus 1.03 raised to power 7r minus 1.03 raised to power 6r minus dot 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 r should be equals to 0, right? Let us verify this. Yes. So now we can see that this is our geometric progression. This is in our geometric progression. So what we will do, we will write this as it is, 8,000 into 1.03 raised to power r raised to power 8, sorry, minus, I am taking r common from this expression, this part. So what we will get? We will get 1.03 raised to power 7. Now it will become plus because I have taken minus here, and this will become 1.03 raised to power 6 plus so on dot 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 plus 1 should be equals to 0, right? Now you can see that this is a geometric progression, right? In this geometric progression, what will the first term? See, you can see this is first term. You can assume this is a first term because it's written first. But if we do it smartly, see, this is a sum. This is the sum only. So if we assume this as a first term, you can write it in a reverse manner also. Let me let me clear this. See, we have to find 1.03 raised to power 7 plus 1.03 raised to power 6 plus dot 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 plus 1. You can write it, you can write it in reverse manner also. Nothing will change. 1 plus its previous term will be 1.03 raised to power 2, like this plus 1.03 raised to power 6 plus 1.03 raised to power 7, like this we can see. So if we write in this manner, or if we take this in this manner, we will get advantage, the advantage in calculation. What's the first term I will have? I will have the first term as a is equals to 1. What's the common ratio from here? You can see its common ratio is 1.03. So I will okay, and what's the total number of terms here? Total number of terms, see, again pattern. if this is the second term, sorry, basically when you, okay, let me write here what will be the, it's just previous term, it should be 1.03 raised to power 1, then it will have 1.03 raised to power 0. So basically its next term will be 1, and this will be like this, 1.03 raised to power 2, and like this, right? So please see, if this is the second term, the power is 1. If this is the third term, power is 2, right? So if it has the power 7, so it will be which term? It will be its eighth term. So basically total number of terms is basically 8. So now apply the above results here, right? So okay, let me take this on another page. Let us apply. So this is 8,000 into 1.03 raised to power 8 minus r, and you know the sum of n terms of GP when r is greater than 1. So Sn is equals to a r raised to power n minus 1 upon r minus 1. So first term is 1, so I will write 1 here. R is my 1.03, so it should be 1.03 raised to power 8 minus 1, because total number of terms are 8 upon 1.03 minus 1. This should be equals to 0. So I can put this whole term to the other side. So this is 8,000 into 1.03 raised to power 8 is equals to r times 1.03 raised to power 8 minus 1 upon 0.03, right? So from here we can calculate r. We will shift this to the other side, so this will become 8,000 into 1.03 raised to power 8 into 0.03 upon 1.03 raised to power 8 minus 1. So this will give me the value of r, and this complete our question. So from this way we can calculate the how much installment we have to pay, right? I hope you are getting this solution. So you, from the calculator, you can calculate these values and check your answer, it will be correct. So I think its answer should be r is equals to 1139.65 dollars, right? So you may verify it with your calculator. If you have any problem, please let me know in comment section. Is your answer coming or not, right? So that I can help you. If you have understood this question, you can see one more question. See, this is the question from your textbook, right? So what's the question is saying? See, he takes out a loan of this. So my principal is how much? My principal is $15,000 to furnish his new student apartment. The terms of the loan are that he will pay equal monthly installments. So he wants to pay monthly, and interest is calculated monthly, so interest is also calculated monthly, and it's charged at 12% per annum. So my rate of interest is 12% per annum. The loan is to be repaid in 2 years, so my time is 2 years. So first of all, I will adjust these parameters. Since it's going to be a monthly payment, so I will write number of repayments here, number of repayments. So what will be the number of repayment? Since I have to pay monthly and I have to pay for 2 year period, so it will be 2 into 12, that is the 24 repayments. Rate of interest, rate of interest, adjusted rate of interest. Since I have to pay it monthly, so I will divide it by 12%, so it is the 1% per month. It's per month, not per year. Now what will happen? See, I have to pay monthly. If you see in that manner, see, you have taken a loan. So after first month, again I will explain in the similar manner. See, after the first month, how much amount I will have as a due amount, right? So since, see, A1, what will be the A1? See, I have, see, initially my total loan was 1500. I have to pay the interest on this as well. So how much in total in due amount? So 1500 into, it will be 1.01. The factor for this 1% will be 1 plus 1 upon 100. This will be 1.01. This will give me the total due amount after first month and before the payment, right? But I have to pay also. So let us suppose R is my EMI, or you can say monthly installment. So my total due amount will be this minus R. So this is the first EMI. After the payment of first EMI, you will get this. What will happen for the next EMI? Similarly, for the second month, first of all, how much total due I will have? See, after second month, I have to pay interest on this A1, because A1 is my total due after the payment of first EMI. So I have to pay the interest on this. So how much total due? So A1 into 1.01, this will be my total due after first EMI. But before the second, or before the second, or you can say at the second month, I will pay the second installment. So the total due after second EMI will be this much. Let us expand this. So it will be 1500 into 1.01, this minus R. See, this is my total A1. This is the complete expression for A1, right? Into 1.01, this 1.01, and again minus R. So let us simplify it little bit. So this will be 1500. This is the single term, and right, this is the single term, and we have to multiply this by 1.01. So 1500 into 1.01 square minus 1.01 R minus R. So this is my total due after second payment, right? What will be the next? See, after third payment, right, what will be the total due? So similarly, it will be A2 into 1.01. This will be the total due, but I will pay something, that is the R. So this will be the total due after the third payment. Let us put the value of A2. So what's the A2? It's 1500. This is the expression for A2 into 1.01 square minus 1.01 R minus R, this into 1.01 minus R. So let us simplify this. So this will become 1500 into 1.01 raised to power 3 minus 1.01 square R minus 1.01 R minus R. So this is the total due amount after third payment. Now please observe some pattern. Is there any pattern going on? Yes, there is a pattern going on. If you watch your A2 expression, A3 expression, A1 expression, you will observe a pattern, right? Now I have to pay total 24 repayments, right? I have to pay total 24 repayments. We have calculated, see, number of repayments is 24. What it means? It means after 24 repayments, my total due becomes 0. Then my close will, then my loan will get closed, right? So can I write A24? What will be the A24? A24 will be the total amount due after 24th payment, and according to question it should be 0, right? So how much A24? Can we write the expression for A24? Yes, according to this pattern. See, if you are writing third A3, so it start from the third power. So now I'm writing A24, so it should be 1500 into 1.01 raised to power 24 minus 1.01 raised to power 23 r minus 1.01 raised to power 22 r, like this, and it will continue minus dot 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 r should be equals to 0. Now please see, this is a equation in which we have only one unknown, that is the r. So we have now one equation, one unknown. We can easily simplify and solve this, right? So for simplification, I am taking this to the next page. So see, so now we have to solve for r. So this will be 1500 into 1.01 raised to power 24. From this expression I am taking r as a common, so minus r will be taken as common. So what we will get? We will get 1.01 raised to power 23 plus 1.01 raised to power 22 plus dot dot dot. In similar manner, at the end we will get 1 should be equals to 0. Now this is a geometric progression going on, in which you can assume, you can take a equals to 1. I will see, this is the sum of the geometric progression, so it doesn't matter I see from this side or I see from this side. This, it is the first term a. What's the common ratio will be here? Its common ratio will be 1.01. if you see in reverse manner, right? This is the first term, it's just a previous term will be 1.01 raised to power 1, then it becomes 1.01 raised to power 0. So common ratio is this. How much total number of terms it has? See, if this, see, this one is what you can write it like this, 1.01 raised to power 0. See, if this is the first term, your power is 0, or think in this manner, if its power is 0, its first term, its power is 1, its second term. So if its power is 23, it will be your 24th term, right? So we got all the parameters of this geometric progression. Now just put in the value. So it will be 1500 into 1.01 raised to power 24 minus r, and the sum of n terms when r is greater than 1 is a r raised to power n minus 1 upon r minus 1. So r and a is 1, r is 1.01 raised to power 24 minus 1 upon 1.01 minus 1. So, and this should be equals to 0. Now I am putting this expression to the right hand side. So this will be 1500 into 1.01 raised to power 24 is equals to r into 1.01 raised to power 24 minus 1 upon 0.01. This, from here now we can get the value of r. So this will be 1500 into 1.01 raised to power 24 into 0.01 divided by 1.01 raised to power 24 minus 1 is equals to r. So I hope you are getting this, how I have calculated this expression, and from the calculator you can verify this and you can calculate this. You will get the value of r, I think 70.61 approximately. So I hope you have understood this. So if you have liked this video and discussion, please like this video, subscribe this channel for more questions and discussion on IB mathematics. Thank you. Thanks for watching.